So thank you for the mic and with all you here this afternoon. I'm pretty sure that you had a good lunch with a glass of beer, glass of wine. I can see more than 300 participants nodding their heads. So before I start, I would like to confirm that you should see only 3 palettes on the slide in my presentation right now. If you see more, it's not an issue on my side, neither on Zoom. So to start, I will give you a small, let me just go through my screen. I lost my mouse. Where is my mouse? Ah, caramba. Okay. So I will just explain the small logo, which is at the top of all my slides. I'm part of a small team of 4 people listed on the slide, and we are running an HB9 TV network. It's started a long time ago in 1993 with a first relay on top of Jura, about at 700 meter high over here. And later on now we have 4 linked relay working on DVB-S technology, which we manage partially by DTMF and also through Hamnet. So one of them, HB9 TV3, is linked to the BATC live video streamer. And we live only on donation, and the 4 of us are managing this small network. As you can see on the pictures, it's also linked to a very nice relay on top of the Shilton. It's called HB9F, and from there we can go to different locations. Unfortunately, right now the HB9F have some issue, and the link is cut. It works only from Shilton to us. Okay, that said, let's start about what you want to hear. How did it start? Well, it started, guess what, with a very nice article on the CQ-TV from Jim about a new transistor, LD-MOS transistor, and a homemade amplifier. And like Jim, we use the very inefficient Spectrum boards with the huge head output. So we decided, Pierre-André and myself, to build this PA. But after spending some time evaluating if we do it from scratch or we buy the Ampleon palette, we decided to go for the palette. So despite the warning from Jim, who had blown one up, so the project is based on the Ampleon palette. Use the same LD-MOS transistor as the project from Jim. You can see that the circuit is very simple. You have 6 pins to manage it. You have RF in, RF out, the drain source voltage. You have 2 connections. You have the gate voltage, and you have a temperature sensor. You can see that the board is really very small. It's around 50 millimeter by 30, by 34. is smaller than a credit card, which we use to buy it. So it's a really powerful module. As you can see on the extract from the datasheet, you can go up to 300 watts. You have a gain of average gain of 70 dB. And at the maximum power, the efficiency is very good with something like 60%. I just want to make you aware of two things. Is if you read carefully the datasheet, all the measurements have been done around 25 degrees. And if you go down the features and benefits list, you will see that the palette got built-in temperature compensation networks. So following Jim's warnings, we went looking for information how to use at best palette. And we found two very interesting applications, not from Ampleon. The first one on the assembly usage of the palette. I will recommend that you read really carefully this document. You got information about DC biasing of the circuit, about the shielding of the palette, about the cooling system to use for it, and also on the thermal sensor usage. The second application notes is about LDMOS bias module, which incorporates temperature compensation. And this board can be buy from Ampleon. But the most interesting contribution was from Marco, and was published on the AMSAT-DL on the forum for QOSA under the NB narrowband transporter and the hardware. And there I started a discussion to talk about the Ampleon 250 watts palette we're using. And the very important thing is that, like us, Marco, I find out that the temperature compensation, which is inside the palette, is a problem to use it on the DATV. There is a NTC on this board, which is feeding the bias input current to ground. And he was able to get from Ampleon technical team the characteristic of this NTC, which you can see on the screen here. And you can see that the average temperature at 25 degrees, it's around 1500 ohms. And as the temperature of the palette increase, the NTC resistance drops very quickly. And when you are running the palette, you see that very quickly that your power is going away. And that, of course, it's a catch-20 because you increase the gate current and then the temperature goes up and so on. So he was unable to find more information from Ampleon tech guys. So he did some reverse engineering and find out, you see on the pictures here, that the NTC is on the palette on the input side. It's called R4. And if you remove it, you have no more control of the gate current by this NTC, internal NTC. So that's something very interesting. Of course, due to the temperature, the palette still has dropped a little bit of power. And of course, you need to be careful to not go to too high temperature and blowing up your palette. But for that, you can use the temperature probe, which is inside, and which is the same NTC. And his recommendation is not to go over 60 degree, which is about 400 ohms if you measure the NTC. So that's really something to remember. At 40 degree, it's about 600 ohm. So this done, took us some time to design a copper soul that we wanted to have, to not make the palette directly on the radiators, to be more flexible. So we did a small soul on which we have the palette and 2 aluminum plates on each side. And for this side here, we use just aluminum H in the U form to make these 2 sides, where you can see the pass-through capacitors for the tension, for the gate, and for the temperature NTC. And of course, put some decoupling on the drain source to ensure stability of the board. So now the next things to think about it is or to put the bias tension to this palette. So looking through the internet, well, we found some design, and the basic one is from ON1BTE. It's a very simple circuit using the 28 volts we are using from the palette, and some regulator chips. And we have also included optocoupler, because we are remotely doing the PTT through the coax cable to the dish. Things which is quite important is that if something goes wrong on that, you could have the 20 volts going straight to your bias, and of course burn out your palette. So it's quite important to put a zener here to limit the tension going to the palette. So that's the first circuit we are using to test our palette. As you can see, is no temperature compensation on that one. So we found another design for the bias circuit, this time with temperature compensation, which is through a diode here. And again, we have also included optocoupler. And he used a very interesting regulator chips, which has enable ports. So could be used as done here to do the PTT, but we think also later on to measure the NTC and to make a shutdown if the temperature goes too high. We've also included a zener to be sure that we not make mistakes going with too high tension or something wrong going between the different regulators. You have pictures of the prototype here, and with the zener, with the diode here. All this is going to go through a hole on the copper soul. And the last one is the circuit from Ampleon. You can see here the schematic of it. And I was lucky to find out on the net, in fact, the Gerber files and all of the information needed to produce the small circuits. You see the pictures here, which is described on the datasheet from Ampleon. So that was done by Sarah, MESGE. So I just took the information, sent it to a PC board producer in China, and a week later had the boards done, and with one side already with the component loaded. Unfortunately, we made some mistake ordering one of the components here. It was not on the good form factor, so we are waiting for the chip to be able to test this circuit also. And the regulator chip also have enable ports, so we think also to use it for PTT. And the module has no Zener at the output, so we think also that that should be done. And in this case, the temperature probe is a transistor, it's a BC847. So now we have almost everything to start testing our boards. But going from the ports down with, I'm using right now DA-TV Express board. Needed some intermediate PA. So we found this very interesting Skyworks small module, which is very efficient with very high gain. You can see about 35 dB. It runs from 5 volts, only one power supply needed. It's easy to switch in on and off. So you see here, I will just put it on a small radiator to do the test. And I'm using that as the intermediate PA in front of the Ampleon board. So we did the first state at Pierre-André location a month ago. And that was done without modifying the Ampleon palette, without taking out the NTC. And we could confirm that it was really difficult to have a stable operating point that way. I forgot to say that on the Ampleon datasheet and on the guidelines, they are doing cooling with water, and the recommendation is very cold water. It's about 5 degree water. That is a recommendation. So can imagine that was not working very well. We could get the power, but it was difficult to get it stable. So that's the test setup I've been using. So the ports down, the DA-TV Express card, the Skyworks PA, and the Ampleon PA. And this time without the NTC on the board, and using the simple BIS compensation circuit. DVBS, symbol rate 500 kilo, and FEC 2/3. Ampleon workings at 20 volts, 28 volts, and with a BIAS setup at 500 milliamps. So before showing you the result and the spectrum, I'll just warn you that fortunately my HP Spectrum had an issue on the frequency span switch, and I could not work below resolution below 50 megahertz, so useless. So I did use SDR Angel with Lime SDR to display the spectrum. I must admit it's quite difficult to measure all these parameters at such a power. I was not equipped with all the gear I needed, so I had to wait some coupler from China to be able to support the power. And I use a long cable to do the load. And as the design was on the table, is also certainly some effect on the ground loop and maybe not to tie coax cable. Anyway, this is the result we got. So you can see that for around a half watt, got 50 watts out. And with quite nice signals, I had about 30 dB from the top to here. So, and that was very stable, no problem. It's not a very big radiator, but a big fan on it, and no issue, and the temperature was stable and without any problem. Next, we did it at 70 watts. You see it's about really about 20 dB gain. Here also it's good. Here we are about minus 82, minus 52, so again around 30 dB gain. And we stopped at 100 watts. And here I start to degrade a little bit. You see some things on both sides. Maybe need some filters also between the ports down and the amplifiers. But here, if we take it, it's about 80, minus 80, 52, so it's about 28 dB, which is quite good. We've also seen that if you adjust the gate current, you can also influence quite much this curve and to make it better or worse. So a really nice way will be to have a control of this current by really a microprocessor to adjust it really for each power you want to run it. So that's it for the presentation. I have also give you here the references from Ampleon, from the Skywalk amplifier, and the talk on the forum from AMSAT-DL about the Ampleon palette by Marco. So thank you very much listening to me, and I hope that you could translate automatically my French English in fluent English. Back to you, Dave.
Okay, Michel, thank you very much. Your English, as usual, was perfect. Very good, thank you. A very interesting talk to see how you have managed to tame those amplifiers. It's quite a challenge, and I don't underestimate the amount of engineering involved that. We've got a couple of questions on the questions and answers. Do Ampleon part number club projects qualify for bursary funding? It depends what you're going to use them for, Vincent. Personal use, no. But if they were for an exhibition station or a repeater, we'd have to think about it a bit more carefully. question from me, Michel. What do you envisage driving the Ampleon with when you put it on the satellite? Presumably not DATV Express. Yeah.
Yeah, well, I use, let me just remove that, the questions from, so I can see. Basically, I'm very lucky because I got a huge parabol, which is on a trailer. Is about 80 meters, 100 meters from my shack on the field next to my house. And it was the trailer used for the Swiss TV reportage when they were outside the studio. And the trailer is equipped with 3 meters dish. So from the shack, we go at 432 megahertz. And then we have HIDES up converter, which goes 432 to 2 gig, 2.4 gig. And this deliver already half watt is what I'm using right now with the Spectrian amplifier. So behind, I will see if I leave the Ampleo directly on it, running about 60 watts, or if I do intermediate amplifier with the Skyworks in between. So I have not decided right now how I will do it. But the goal is at some time I will have certainly to remove this trailer from the field, which not it doesn't believe I am not the owner of the field. So definitely I would like to have more power to run from 120 meter dish, which I already got on the receiving side.
Okay, Dave G4IUG asks, can you remind him why you had to remove the pallet temperature compensation? I take it that sort of shorts out the gate bias to some extent, does it?
Yes, exact. So basically, what I understand from Marco is that this NTC is in parallel to the bias, and it put down very quickly down the power of the bias, and then of course putting down your power. So the goal is to be able to control, without this NTC, your bias current.
Okay, that's good. And the graphs you showed of the spectrums were with that NTC disconnected, were they?
Correct.
Okay,
Correct.
I think that answers
Yep.
Steve's question. Jack says, have you implemented any protection for high temperature or SWR?
Well, not yet.
Okay.
Not yet. Well, yes, it's just a multimeter.
Yeah, okay.
It's just a multimeter, but I think that the idea is to have a small circuit taking the NTC sensor and deciding, when the resistance go too low, to shut down the bias circuit through the power supply.
Okay, there's another question. What is the linearity over the power range? But I think the DVB-S tests actually tend to show that in the fact that there were no significant sidebands up to 70 watts. I think
that's correct. Yeah.
That's the linearity that matters to us, really. Have you any experience with the double stage amplifier that Ampleon provide? No.
Well, we at some point would say, but it's quite more expensive. And the issue is the same as with the single stage. It also has NTC internal temperature compensation, internal temperature compensation. And without knowing where. So as Ampleon has not published the circuit and where these NTC are. So we decided to stick to the one-stage palette, also due to that we knew from Marco what to do.
Okay. Well, thank you very much. I think that's exhausted the questions. That's a really interesting presentation, because I think one of the biggest challenges, as Colin mentioned, is getting a suitable power amplifier for QO100. We look forward to seeing your further work. Can we ask you to write it up for CQTV once you get a finished unit, please, Michel?
Yeah. Well, you know, when we started to talk about this talk together about more than 2 months ago, I was saying, yeah, it's going to be okay for that time. But unfortunately, it took us, like always, more time that we're thinking for the mechanics to make this copper soul. And then after we had some issue because we ordered the wrong component. So we have just tested with the no temperature compensation.
Okay, that's great. Okay, thank you very much, and we hope to see you on the net tonight. Okay.
No problem, I will be there.
Okay, we'll now take a short break till 2:30 when David will talk about video production. Thank you very much.